Okay, how many of you have had a soils class already? Okay, so a lot of this information you probably know, but you might have maybe not used it in a while. So we're going to go over to some basic soil stuff this morning. So brief little outline of what we're going to cover. I struggled to put this together, I will tell you, because there's so much that I want to talk to you about, but what I was really trying to figure out is, as a master naturalist, what is the most important stuff for you to know about soil? So I look at soils from a variety of perspectives. The College of Agriculture, Food and Environment teaches it a lot in terms of agricultural productivity and use, but we also look at it in terms of ecology as well. So we're going to try to hit kind of the basic stuff, kind of that soil forming factors, soil genesis, a little bit about classification. I gave you a soil planner. You're welcome. I got these from the state soil scientist. That is Steve Blandford. He works for the Natural Resources Conservation Service. They're kind of the keepers of the official soils information for the United States. His office is here in Lexington, but he serves the whole state. And these were produced by USDA. So, and also in conjunction with the Soil Science Society of America. And if you are interested in studying soils on down your academic career, that's a good organization to become involved with and to go to their meetings. So they're pretty extensive. But we're going to talk about soil genesis, classification, a little bit about soil-plant relationships. I know when Joyce Bender was here, she talked about ecosystems and ecoregions, and she touched a little bit on how those soils, how the geology and the soils are influencing those plant communities. We're going to talk a tad about that, a little bit about soil management, and then also about tools. On Friday, we'll be in the field, obviously, and so we'll do lots more hands-on. So you're probably not going to get your hands dirty today. I've got a little demo that we'll do shortly, but otherwise, we're just going to kind of have to think about the stuff and look at some pictures as we go. Any questions before we get started?
So I'm going to cut the lights and
okay.
come back on whenever you want to do your demos. Is that okay?
Perfect. Yep. Ooh, maybe not so much. Y'all will go to sleep. How's that? Is that okay for your recording? Okay. Okay, so the first question is, what is soil? And this is like the audience participation part. So many of you have had intro soils. So what is it?
Minerals.
Minerals, absolutely. Minerals is part of it. Good. It's a big part of it. What else?
Living matter, decaying matter, and organisms.
Absolutely. Organic matter. We kind of lump that into organic matter. Sure. Okay, so we've got half of it. There's two more parts. These are really easy. Water.
Air.
Yep, and air. How much air do you think is in the soil right now outside? Not so much, right? That's filled up. Okay, so we think about soil kind of in a pie chart kind of way, and this is kind of a super simplistic way to look at it, but essentially that's what is in soil. So about 50-50 air and water. That changes obviously with weather. And also with landscape position, potentially. The other half is the mineral component at 45%. So this is the geology. This is the stuff you learned about last week, right? And this little 5% down here is organic matter. 5% is kind of generous. So does anybody know or remember talking about organic matter in soils? About like the average percent organic matter in Kentucky soils?
3 to 5?
Yeah, maybe. That's on the high end. So usually it's like 2.5% organic matter. This is the part that we can change with management. So that's the thing to keep in mind too. Organic matter is really important, but that's really that tiny little piece is how much we can influence. The rest of it is kind of up to geology, position in the landscape, weather, climate, that stuff. Okay, so why the hype? You know, isn't it just dirt, right? I mean, how many of your friends, family, whatever, just say, well, they had a dirt class this semester? I got a lot of flack from my family about how long I spent studying dirt in college. But there's a difference between soil and dirt, right? Dirt's what you tracked in on your boots this morning, and soil is what we use in the ecosystem, the foundation of our Earth, essentially. So the 2015 was an International Year of Soils that was designated by Soil Science Society of America. And you maybe saw these little I Heart Soil things floating around. And then the International Union of Soil Scientists have declared 2015 to 2024 the decade of soil. And so, see their little, how creative, their IUSS looks like little worms.
How is that decided as to what year it should be?
You know, that's a good question. I don't know. This is what soil scientists talk about when they get together. I don't know. I really don't know. So if we think about soil and the components of it, we can kind of think of it as all these different things. These are all the different characteristics that we can use to describe soils. So particle size, organic matter, we talked about that. This particle size is really related to the mineral component of soils. Structure, also related to particle size and organic matter. Color, horizons, pH, ion exchange, these things are kind of the water or the soil chemistry. Anybody going to take soil chemistry? Yeah, it's a good class. It's a little scary, but and then water holding capacity. So these are all characteristics of our soils and how we can describe them, and really kind of helps us determine what our uses for the soils are, but also influences what kind of plant communities are going to live there. Okay, so we're going to talk about physical characteristics. And the first thing is particle size. You all probably have heard this over and over and over, right? So the 3 particle sizes are, as you're jotting things down, sand is the largest, silt is the medium-sized particle size, and then clay is the smallest. So have any of you done textures by hand? Yeah, a few of you, yep. Eric's done lots of them with me. So describe to me what sand feels like.
Like grain.
It's like what?
Like grain.
Like grain? Okay, what were you going to say? It's gritty, right? You know when you've got sand in your hand. Have you ever gotten into your mouth? And like you take like one little sand grain, if you bite on it, it's kind of like runs shivers up your spine. So that's the largest soil particle, is sand. Silt is kind of in the middle. And I don't worry too much about all these measurements. If you really want to dig in, by all means, I'm going to give you some more resources. But I think of soils in terms of like how we can feel them and what those sizes are. So silt's the medium size particle size. And do you know what it feels like? Does anybody remember? We'll get to do this in the field on Friday. Kind of feels like flour. So if anybody makes cookies, not the slice and bakes, not the open the package, put them in the oven, but like cookies from scratch, and you measure out flour and you know how it feels in your hand, that's kind of what silt feels like. And then clay is the smallest particle size, and it feels what? If you have sticky, it's kind of squishy, it's smooth, but it's sticky, very sticky. It may stain your hands. Those tiny little soil particles, they are the teeny tiniest of the particle sizes. They stick together a lot. That's why when we're in the field, we're going to make ribbons. You'll see your ribbons get really big with clay because those particles stick together, but they also can stick to your clothes. So definitely wear field clothes on Friday. And those are the smallest particles. So if we were to take a jug, and we were to shake it up and have some soil in it, we would, as it would settle down, the sand would fall out first. And then the silt would start to fall out, and then the clay. Now in this sample, the clay is still suspended in the water column. And then the stuff floating up at the top, does anybody know what that is? Organic matter, absolutely. So that's the organic matter. So when we see streams and rivers that are muddy right now and they look like chocolate milk, clay particles are generally what's still floating in there. Some silt as well. The sand particles will fall out very quickly. And especially when we get into a floodplain situation and we're flooding it and our floodwaters are up out of the banks of the stream or the river, the sands are going to fall out really quickly. So we might tend to have those larger grained particle sizes on those floodplains a little bit. So you've probably seen this lovely thing. This will not be on the exam, but I can't tell you how many exams I've taken where I had to fill this thing out. Anybody do soil judging on the soil judging team? We do have a collegiate soil judging team, and so you can, when we go out to the field and do the profile description, you can do that as a collegiate team. And I think our new pedologist is on board now and is going to probably offer that either in the spring or next fall. And you'll do lots of profile descriptions, and you start to utilize the soil texture triangle. And that's for you to figure out in detail, numerically, quantitatively, what the partitioning of those soil particles are. So that relative percent of those particle sizes, how many are in a sample in your soil, by percentage is what determines the actual name of the soil texture. So that's how we describe soil texture. It's that percentage of those particle sizes that are distributed in that sample. So you can see that the clay percentage across here, you can have as little as, like, you know, down in here at the 40% clay, 40% of the particles being clay, and it's still considered clay. So those particles are very influential in the actual determination of the texture class. So those are just the texture classes. This is what soil scientists get real excited about. It's like breaking out that percentage. The old school soil scientists would texture by feel, which we're going to do in the field. Then they would you know, have these little contests to see who is right up to like the, you know, little 0.1%, and take it back to the lab, and then they'll do a laboratory analysis to determine the actual percentage. Some of them would like texture by mouth. Don't do that. That's gross. That's just not a good plan. Like, they would try to determine the percent sand based on how gritty it felt on their teeth. Yeah, moving on. Okay, so soil color. So we've talked about soil texture. Now we're going to talk a little bit about soil color. So we have this beautiful, Carmen gifted us, our class, with these, this is a Munsell soil color chart. Anybody seen one like this before? Yep. So this is how we determine soil color in the field. But the reason that we want to figure out soil color, other than just brown, dark brown, red, you know, reddish brown, what have you, we can use those descriptions. But if we use a Munsell soil color chart, we can get a quantitative value for what typically is a qualitative characteristic. So we put a number to something that we usually would just use descriptive words to describe. And so if I am in Kentucky in Fayette County and I have a soil that's a 10YR34, and you are in Western Kentucky in Fulton County and you have a soil that is a, I don't know, a 10YR2, you know, 33, whatever, we both can communicate on the same level and same language, and we know what our soils look like instead of dark brown, light brown. So that's why it's important. The factors that will influence the color of the soil, mostly the minerals. So what is one thing that I hear a lot, and you probably maybe think this too, if someone were to describe the soil in Georgia, anybody been to the state of Georgia? Or anywhere in the south of the United States, what kind of soil do they have down there? That's what people say in the south. Red clay, right? That's what everybody says is red clay. Doesn't necessarily mean that it's clay because it's red, but that red color is very characteristic. It's very weathered. We'll talk a little bit about that in a minute. But that red color is very distinctive. And so it tells us a little bit about the minerals and the basis of that soil. The organic matter is definitely going to influence the color. So, and I'm going to show you some other colors, and then moisture content as well. So let's look at these colors. So there's some reddish colors here, reddish colors here. These are fairly red. Look how dark this one is, all these down here. That dark brown, almost black color typically means organic matter. So the more organic matter is there, the deeper, the darker that color is. So that's the decaying organic matter. So soils can have lots and lots of different colors. The moisture content that we talked about here, typically is, so these soils would be oxidized iron. So we talk about the mineralogy. The red, you may know what iron oxide is called, also called? Rust, yeah. So we have these iron oxides that are in our soils as well, and so that gives us the red color. But then if the soils get saturated and they have iron in them, they can get into a reduced state. So if y'all had oxidation reduction, you know what I'm talking about. It's exciting. Naki looks very excited about redox. Who doesn't want to talk about redox first thing in the morning? So as the water, especially in a floodplain situation, the water table kind of fluctuates. It'll come up. Right now it's probably pretty high, right? And then hopefully later this fall it will go back down. And so that fluctuation in the water table will influence the soil chemistry in those minerals, and that will influence the soil color. So it's kind of exciting to see soils that have those different colors. The modeling, we'd call that modeling. It kind of looks like Rocky Road ice cream. Those variations in the color, and those are a effect of the chemistry in the water table going up and down. Okay, so here's Munsell soil color chart. In the field, we'll talk about how we read that. In the upper right-hand corner on this page, it's kind of in the middle on the new books. This is the hue. So colors described by hue, value, and chroma. The hue is just what color it is. On this page, it's a 5YR. Anybody have a guess at what Y and R stand for? Not year. Yellow and red, because soil scientists are super creative that way. So very straightforward. So yellow and red, and so it's just the numbers just kind of really not even sure how they decided which numbers to choose, but that is the hue, is that 5YR. So you start there. The value is up and down on the y-axis, and so the value is the darkness or lightness of the color, and the chroma is the purity of the color. So if you study the color wheel, same concepts of hue, value, and chroma if you're an artist and you use the color wheel. Okay, so we mentioned this before, but the soil color can change based on different slope locations. So when we're at the top of the slope, this is the summit. So the hillside, and I think I've got another graphic here in a second. So the summit is the top of the hill. And so what generally happens at the top of the hill in terms of water movement?
It moves on down.
Absolutely. It doesn't hang out there, right? So gravity's going to take it on down the hill. And so some of that water, right now as it's raining, that water's going to infiltrate through the soil profile. Some of it's just going to run off on the surface, but it's going to infiltrate through the profile and maybe even run subsurfacely on down the hill as well. But it's not going to hang out there. And so these soils tend to be what we call weathered. So they've had lots of water that has moved through that profile over time, lots and lots of time. And so those soils usually are very well developed, more mature soils, and they would have more of a reddish color. And then as we get to the shoulder is kind of, you know what? Let me do this. I think I saw a marker. Oh, they're over here. Let's do this. Carmen, if I can. I don't know if y'all can y'all see that over here? Or should I put the screen up? Let's put the screen up just for a second. Let's do this. Let me turn that off. I don't know how to blacken that without totally turning that off. We'll just do it. Okay. Let's talk about it this way. Okay. Hill slope continuum. Summit. There's your profile. Shoulder. Anybody know what this is called? back slope. So we're going to have a profile here. And then we got a foot slope. That's down here. And then we'll have a toe slope. Our soil's going to look different there. And then we've got a stream terrace. Stream terrace is the old floodplain. I don't like my little squigglies here. It's kind of exaggerated a little bit. Okay, so this is like kind of the landscape continuum, and as it's part of the soil forming factors, but landscape position is really going to affect water movement, deposition, erosion, all those processes that are going to be at work at soil formation. And so these things also will influence soil color, because our summit will typically be a very deep and well-drained soil. Our shoulder will have a fair amount of erosion. This is probably the steepest part of the landscape. So lots of erosion there. You may see rock outcrops as you walk around. Back slope is here, still influenced by erosional forces. Foot slope, you're going to start to see some deposition. Toe slope, also some deposition here, but at foot slope you may have both erosion and deposition. Toe slope will be mostly deposition. Stream terrace is the old floodplain. So this is going to have influence also from not just deposition by gravity, but also deposition by flooding, right? Old material, older material. So maybe alluvium and colluvium. The floodplain mostly is just going to have alluvial. These are these words, alluvial, alluvium. I think there's just one U in it. And this is colluvium. You don't have to be a good speller to be a soil scientist, apparently. So colluvial material is moved by gravity. Alluvial material is moved by water. So if you think about how the water table may fluctuate, the water table here is certainly going to be very much influenced by this water body, right? The water table here, not so much. So you can, so down in these positions, and we're going to go to a pit in one of these, in the foot slope, toe slope area, that water table is going to be fluctuating a lot, and so you might get those variations in the color. Has everybody got that? Before I put the screen back down? Y'all good? Okay. Sorry. Oh, good question.
Is this going to be more anaerobic? Probably degrades.
Oh, very good question. We're going to talk about that. I've got a slide on it. Okay, so the color here, this is called a drainage, this is labeled drainage way, but it could be a stream terrace or floodplain. And so you see how dark that material is. So Carmen's question is there more organic matter in that floodplain? What do you think? As indicated by the color, yeah, absolutely. Because saturated conditions, the respiration, the processes that are the carbon cycle slowing down, you probably have accumulation, a sink of carbon there, right? Okay, soil structure. So soil structure is really just how those particle sizes are arranged. And you may hear people call them a PED, P-E-D, like you get a handful of soil and how those particles clump together and in aggregates is how we describe the structure. This is so much better described in the pit, and we will talk about this in the pit, but it's how these, so this is kind of single grain, typically that's a very sandy soil. Granular structure will usually happen near the surface. Because you've got, what's going on at the surface of the soil? What happens at the surface of the soil?
You got roots,
Got roots. What else?
erosion.
Erosion, potentially, yep. What else? As humans, what do we do with the soil that's at the surface? We may compact it, could be. Do we disturb it? Yeah, if we're going to disturb soil, it's usually there at the surface, right? So maybe in terms of plowing, mixing, digging, but lots of root action, lots of microbial activity concentrated in the top of that soil, the topsoil. So the granular structure is usually a result of that churning and disturbance that's going on there. Blocky, and we may even hear the terms blocky, subangular blocky, depending on how deep you want to get into the soil description. This is when we start to have clay content. As we move down the soil profile, remember we talked about those clay particles being